You walk into a room. The air feels weird. No one has said anything, but you know something is off. A physicist rolls their eyes at you. Vibes? What do you even mean by that? And this is where most people panic, but not you, because today we're about to break down vibes into hard science, wave physics, probability fields, and entropy reduction. Not only are vibes real, but we can prove good energy mathematically, and by the end of this, even the physicist will have to admit it. To keep a physicist from smirking, you need a definition that actually holds up in scientific terms. Here's the version they can't argue with. Vibes are emergent resonance patterns within interacting dynamical systems, where phase coherence and constructive interference create structured, low-entropy states that manifest as stability, synchronization, and perceived harmony. In simpler terms, when things sync up, they feel right. When things fall out of sync, they feel off. And this isn't just a metaphor. This is physics, neuroscience, and information theory in action. Let's break that down. Everything in reality, light, sound, even brain activity, behaves like a wave. And waves have three critical behaviors that explain vibes. Constructive interference. When two waves are in sync, they amplify each other. Good vibes. Destructive interference. When waves clash, they cancel each other out, creating noise. Bad vibes. Resonance. When oscillators naturally sync up, they stabilize into a predictable rhythm. Flow state, group chemistry. This isn't woo-woo. This is why. Sound waves can reinforce each other to form harmonics. Neurons firing in sync create clear, focused thought. Even social groups fall into patterns of synchronization. So, if vibes are about wave interactions, what about good energy? Can we prove that? Yes, but first, let's define it correctly. Good energy is a phase-coherent, low-entropy state where constructive interference sustains order beyond statistical probability. What does this mean? It means that good energy is a well-structured probability wave. Good energy is a system resisting entropy longer than expected. Good energy is emergent order in a field of randomness. Here's the math behind it. Probability waves and quantum coherence. Wave function superposition. A system exists in multiple states until it collapses. Coherent waves collapse into predictable patterns. Good energy. Quantum entanglement. Correlated particles remain synchronized no matter the distance. A literal high-vibe connection. Decoherence. When external noise disrupts coherence, randomness increases. Bad energy. Entropy and information theory. Shannon entropy. Measures randomness. Lower entropies, higher order, good vibes. Fourier transforms reveal hidden structure in seemingly chaotic signals. Self-organizing criticality shows how systems naturally settle into stable, structured states. Wave interference and synchronization. Phase locking value, PLV, a measure of how synchronized oscillating systems are used in physics and neuroscience. Resonance cascades. When enough individual systems sync up, a network-wide coherence emerges, whether in neurons, social groups, or even weather patterns. In short, good energy is a statistical improbability where a system holds coherence longer than expected. It should fall apart, but it doesn't. That's why we notice it. Vibes are emergent resonance patterns in oscillatory systems, mathematically describable through constructive interference, phase coherence, and low-entropy probability waves. Good energy is simply a state where a system resists entropy longer than expected, forming a stable probability wave. At this point, the physicist is either intrigued or pretending not to be. So if they still laugh, just remind them that laser coherence, synchronized neural oscillations, and Bose-Einstein condensates are all real-world proof that sometimes reality really does fall into place better than expected. That's good energy. And now you have the math to back it up.